Hi, good afternoon. Today we continue from page 38 to 40. There is one important topic in this page, which is diffusion. Diffusion has a general meaning for every particles which can move from high concentration, as you can see on the screen, from the high concentration to low concentration. This is very important for our life, and it's happened same in our lungs when we are breathing. The concentration of oxygen gas outside is much more than inside of our body, so that our lungs can absorb the oxygen from the outside to our body, and also it can move to our blood from our lungs. This is because of differences between concentration. And reversely, also concentration of the carbon dioxide in our blood is much more than higher than is compared to outside. That's why when we are breathing, carbon dioxide can move out from our lungs. So the definition could be a random movement of anything, but here in chemistry we are talking about atoms and molecules, so we can consider for atoms and molecules from a region, a place which can move from higher concentration to a region with lower concentration. This picture also can show a meaning of diffusion. The particles here are moving from high concentration to low concentration. This movement is by themselves, and there is no rules behind of them, and they can move randomly from the high concentration to low concentration. This event not happen in solid because, as we know and we studied before, solids particles and atoms cannot move. They just vibrate in their position, so they cannot move too much. But in contrast, in gases and liquids, because particle can move, so we can have a diffusion in liquids and gases. But which one is faster, which one is higher in gas? Diffusion is in gas is much faster than liquid, because the particle and atoms is far away from each other, and they can move more freely, as we studied before. This is an example of permanent permanganate in water. This is the form of permanganate is liquid form, and when they drop in the water, after a while, after a few steps, they diffuse and they sprayed in all parts of the glass here. So another example for gases, I put another example for gases. Here there is two balloons and separated for hydrogen and oxygen gas. These two gases are separated, and when you open the pipe, when you open the way for the pipe, and gas can move from the high concentration here. Oxygen has the high concentration here, but there is no any concentration for oxygen in another side. In contrast, hydrogen gas has much more concentration here, high concentration, but there is no any concentration for hydrogen. So once you open it, they can move to another place, the opposite side, but it takes a time. It takes a time, and after a while, the two balloon can be adjustable, can be equal form of concentration. One experiment for ammonia and hydrochloric acids fume, which can diffuse in different rate. So imagine we have a glass tube and the cotton wool, which is soaked in HCl or hydrochloric acids, or another side which is same situation with ammonia, and these two gases can be sprayed from the cotton wool. When they spray and when they reach to each other, they can react chemically. And after they spray and after they diffuse, the white ring from a reaction between these two gases happen and created this position. Interestingly, it's not happening in middle. That means one of these, like ammonia, can spray faster and move until here, but another one, which is HCl, can move slower until here, and in this position they can react to each other and create production. The production is white ring. So after this experiment, we can conclude that lighter molecule, here is ammonia, diffuse faster than heavier molecules. Heavier molecules here is HCl, hydrochloric acid, and lighter molecule is ammonia. Ammonia can move faster, diffuse faster, and because of the molecule mass. Another rule that we need to know is temperature and pressure. If we increase the temperature, as we learned before, particles, atom can move faster. Here, this is the example for temperature. I put it, and when you give a heat to our container, the particle and atoms can move faster, and they can transfer to the balloon, and yeah, they change the balloon. So another factor is pressure. When we increase the temperature, the pressure will be increased also. While we increase the temperature, as we know, the particles, atom can move faster. They can heat to the walls, container. They can heat and they create a higher pressure. They increase the pressure inside, in that we call internal pressure. And yeah, this is our topics for today about the diffusion. I summarize and I explain the whole of the concept. These are your questions. The first question, as you can see on the screen, you can take a screenshot or pause the video to read completely the question and give me the answer, please. This is also the second question, and this is also third question, and that's all for today. Thank you so much. Hope you are staying safe and everything would be fine for you.